Good evening students. So let us move on to the reverse biasing of the PN junction diode. Okay, so we have already seen the forward biasing. In the forward biasing, the p-type semiconductor was connected to the positive terminal and the n-type semiconductor was connected to the negative terminal. And now let us see the reverse biasing. So I have shown the reverse biasing circuit over here. In the reverse biasing, p-type semiconductor is connected to the negative terminal and n-type semiconductor is connected to the positive terminal. So in the p-type semiconductor, we are having much of the holes. The majority carriers are the holes and the minority carriers are the electrons. And in the n-type semiconductor, the majority carriers are the electrons and the minority carriers are the holes. So with these accumulated charges, we have got the potential barrier over here. So potential barrier previously was, let us say it is EB over here. Potential barrier I have shown over here. Now what happens is that when the negative terminal is connected to the p-type semiconductor, the electrons are very much attracted to the holes. Electrons are of opposite charges, that of the holes. So opposite charges attract each other. So electrons get attracted towards these holes, and so electrons move from here, from the battery, from the negative terminal. They move from here and they attract the electrons. So all of the electrons push a force this side, and some of the electrons also get neutralized from the electrons, also recombine. Some of the electrons also recombine. So electrons will move from here and some of the electrons also recombine with the holes over here, and so this shifts my depletion layer from this to this. So previously my depletion layer was this much, and now my depletion layer has shifted to this point, shifted point of the depletion layer. Similarly, the holes will move from here and they will get attracted towards the electrons of the n-type semiconductor. They will get attracted towards the electrons of the n-type semiconductor. So my electrons will be attracted with the holes over here. Okay, so what will happen again? They will push all the electrons this side, and my depletion layer will now shift it to this point. So this dotted point is the new depletion layer formed. The new depletion layer formed when voltage is applied. New depletion layer. New depletion layer when voltage is applied. Okay. So previously my potential barrier was narrower with connecting the battery with the negative sign to the negative terminal of the battery to the p-type semiconductor and positive terminal of the battery to the n-type semiconductor. My depletion layer gets broader. Okay, so in the case of reverse biasing, my depletion layer gets broader or widened. We can say it gets broadened or widened. My depletion layer gets widened. So what will happen? Let us draw the potential gradient and potential barrier. So previously my potential barrier was, this was my positive potential. So my potential gradient was this. Potential gradient is nothing but the slope. So potential gradient was this. Then so this was my previous old potential barrier. Okay, and my new potential barrier. So my new potential barrier will be from here. Let us say it will be from here to this point. So my new potential So my new potential barrier will be this much. So my barrier has increased, my wall has increased, my barrier is increased. Electrons which were being attracted over here and was wanting to go over there, now they will have no attraction only because my wall is increased. They will not having any relation with this hole. Okay, so now my electrons will not be able to move from this region to this region. Also my holes will be not able to move from this region to this region because my barrier is increased. So in this case, my PN junction diode behaves as an insulator. It behaves as an insulator. Okay, so let us jot down the points. The first point is that depletion layer widened. Second point, barrier potential increased. Okay. Third point, electrons and holes will not be able to move from one region to another. Okay. Fourth point, PN junction behaves as an insulator. Okay, it behaves as an insulator. Okay, so although my current will be not constituted with the help of majority charges, because my electrons are majority over here, they will not be able to move over in the P region and not be able to recombine and not be able to complete its path. And also my holes will be not be able to move from P region to the N region and will not be able to constitute any current. But still a very small amount of current flows. What is that current? That current is due to the minority charges. So my electrons from this region will move towards this region, constituting a very minute current, and that at the voltage which this current is constituted is known as the breakdown voltage, and the current which is constituted with the help of the minority charges, that is known as the reverse current. That is known as the reverse current. Okay, and the voltage is known as the breakdown voltage. It is known as the breakdown voltage. Okay, so in spite of these electrons will not be able to move in over here because my depletion layer has got widened, but these electrons will move from this region to this region because electrons can easily from here the electrons can easily be traveled. As I am applying the voltage, electrons are going from here and they are recombining, and so these electrons can easily move from this region to this region, and they will constitute a very small amount of current, and that small amount of current is known as the reverse current, and the voltage at which the reverse current flows is known as the reverse voltage or the breakdown voltage. And this concept is being used in the Zener diode, which is a special type of diode that works in the reverse biasing condition. So this concept we will be using in the Zener diode, which is the application of the PN junction diode. Actually, the applications of the PN junction diode, many diodes can be formed with the PN junction, so which we will be studying in the next videos. Also, we will be studying about the transistor. So let us jot down the main point, that the current with the minority charges constituted with the minority charges forms reverse current. And the voltage, the bias voltage at which it occurs is known as breakdown voltage. Okay, the voltage is known as this is the bias voltage. This is termed as the bias voltage, means we are applying the voltage over here. So actually over here my V will be in the direction, will be also in the direction this. Okay, so my net V will be equal to, V bias plus EB, V bias plus EB. So at some of the bias voltage, my electrons will move from this side to this side and they will conduct the electricity, which is very minute, which is very much lower. It is of the order mu ampere. Reverse current is of the order mu ampere. It is very low. So my V bias at that V bias at which this current starts flowing, means my charges move from minority charges move from one region to another region. So from here they will constitute from this electrons will move from here to here, and my current, very minute current, will start flowing from positive terminal to the negative terminal. So that current is known as the breakdown, is known as the reverse current, and that bias voltage is known as the breakdown voltage, and that bias voltage is known as the breakdown voltage. So when I apply my V bias, so total V will be V bias plus EB. So when electrons will flow from this region to this region, my V will be equal to V bias plus EB, and that V bias will be known as a breakdown voltage. Okay, thank you. Please share my videos, please subscribe my channel, and if you have any doubt you can ask me in the comment section. Thank you.